Hi everybody, before we move into any further calculations using the one-way ANOVA information and in regards to the one-way ANOVA, I think it's important that we cover something called the source table because it's useful to help us in all of those calculations. And so we'll talk about that here. So as you've seen, the ANOVA calculations include a lot of information. There's a lot of things going on, hence the word, the omnibus test. It's including lots of things at once. So it is useful if we can keep track of lots of those sources of information so that we can easily access them later. For example, as you saw when we calculated the post hoc test in that video, we needed to find the mean squares within value. And of course, we can go back inside of our math if we know what we're looking for. Otherwise, it's nice to have a nice reference to see where the mean squares within and what that is and what that value is. So we're going to use other elements as well when we calculate things like the effect size for the one-way ANOVA. But to do that, it's going to be a lot easier if we have a source table. So I'm going to explain in this video how we create a source table, where we get the elements from, and then of course we'll see how to use it in future videos. Okay, so this is a source table. It doesn't always look green, of course, but this is how it's always organized in any publications. This is also how SPSS formats it. That's a statistical software that many social sciences use. So as you can see here over on the left, this is the source of the information where we're getting it. Now there's the between groups variation and the within groups variation. This is the numerator stuff, and this is the stuff in the denominator of the equation, as we'll see. And then there's the total. Okay, now we'll see how this works all in just a little bit. So we're going to need the sum of squares for the between groups variance. I'll show you what that is and how to get that. We'll need the same sum of squares for the within groups variance, the degrees of freedom for the between groups variance, and for the within groups variance. This is the mean squares for both sources. Now as you can see here, I've merged these cells because the F value isn't from the between groups variance or the within groups variance. It's the between groups mean squares divided by the within groups mean squares, and so it goes with both of them. So I'll just keep those on in a merged sort of file. And same thing for the p-value or the statistical significance value. Of course, that refers only to the f value, of course, so it isn't just one of these or the other. But now let's take a look at the f equation, and I'll show you where we get all of these values from that overall f equation. All right, so here's the f equation down here. In this particular example, I'm just showing you one with three means or three groups, right? So there's group 1, group 2, and group 3 there, and same thing down here again. All right, now it's really not difficult to find these, although it's quite a lot to keep track of, I suppose. But the sum of squares for the between groups variance is simply the numerator of the numerator here. So it's all of the math that you do for that particular section of the equation, all right? All of that. Whatever the value is in the end, you simply put there as the sum of squares for the between groups variance. Now the degrees of freedom for the between groups variance is the denominator of the numerator. Okay, so it's just this k minus 1, whatever that happens to be in your particular scenario. In this scenario, of course, there would be three means and therefore three groups, so k minus 1 would be 2 because 3 minus 1 is 2. All right, but it'll be different depending on what scenario we're talking about. The total sum of squares is, of course, this section of the equation. It's just that the sum of the squared values from the entire group minus the square of the sum of the total groups divided by n, of course, the total number of observations. So whatever that value is in your equation, it's simply going to go right there. And of course, the within groups variation is the difference between the total groups variation and the between groups variation, which, as you can see, is just this repeated element right there. So we'll take whatever is in the total variation, we'll remove the between groups variation, and whatever is left over is the variation that is attributable to the within groups variation, or the within groups differences from those subjects. Okay. And then naturally the within groups degrees of freedom, the within groups degrees of freedom is n minus 1 minus k minus 1 right there. The total degrees of freedom is just n minus 1, but of course we don't need that for anything, and so I've never seen a source table that included that. We just need the within groups degrees of freedom, which is of course n minus 1 minus k minus 1. Okay, then to get some of this other stuff here, for example, we need the mean squares for the between groups variance. Then we need the mean squares for the within groups variance. That's very easy to calculate as well because the mean squares for the between groups variance is simply the sum of squares divided by the degrees of freedom from that same source. So all it is this numerator of the entire equation. Okay, so in other words, you'll take the sum of squares, divide by the degrees of freedom, and that will give you the mean squares within. It's all from the between groups of variance, excuse me. but it's just this upper portion of the equation. In similar fashion, the mean squares for the within groups variance is simply this denominator of the entire equation. So it's whatever you arrived at there. If you're doing your source table one at a time, however, it's just the sum of squares for the within groups variance divided by the degrees of freedom for the within groups variance as well. That'll arrive at the same answer. And then, of course, the f value is simply that divided by that. It's the numerator divided by the denominator, the whole thing, which gives us the f value there. We just leave that in there so that we have it all together. Okay, and of course, the p-value is figured out using an appendix. That's the statistical significance level of this particular test, and that'll depend on your test exactly. Normally here you would say the p-value is greater than or less than, and then you'll use the 0.05 or 0.01 criteria. Or you can put in the actual specific p-value, especially if you're using software that gives that to you. Generally, when we're using textbooks, we don't actually calculate the precise p-value, however. We'll just say it's less than 0.05 or less than 0.01. All right, so let's take a look at how to apply this. If I take the data that we've been working with in the last couple of videos, as you saw when I started to calculate on ANOVA, this is a couple of videos ago, I'm using this data here now just to show you how to apply this. So down here I've got the equation almost fully simplified. I've just left a couple of steps here before I actually get to the f value, but this is where we can obtain all of this information. I come down to this step. Once I've solved the numerator of the numerator, that of course is the same thing as the between groups sum of squares. So 175.14 is that same value. The degrees of freedom, of course, for the between groups variance is that 3. Okay, in other words, it's right there. And then to arrive at the mean squares for the between groups variance, I simply take 175.14 divided by 3 to get 58.38. Now I'm going to do that anyway as I simplify this equation, but we can see where that comes from now. Okay, let's hold on to that. We'll come down here now. What we're looking at is the within groups variance. The within groups variance, once again, is the total minus the between groups variance, and whatever is left is, of course, the within groups variance. So to do that down here, that's just this minus that, which of course gives us 28.57. Or looking up here, you can also check your math and say 203.7 minus 175.14 equals 28.57. Or you could also say 175.14 plus 28.57 equals 203.7, although I've rounded ever so slightly. So there you go. There's probably ever so slightly off. All right, and then you could do the same thing here, is you could divide 28.57 by 24 to get 1.19, which is our mean squares for the within groups variation. And so you can see where I've got all those values. So up here, this is the total the total numerator right there. And then down here, that is the total or the simplified denominator. Now, of course, to arrive at the f value, I simply take that, divide it by that, and I have 49.06. And then, of course, we found the p-value in a previous video. You don't need to worry about that right now. Of course, what you do is you go into the appendix of the textbook for the ANOVA distribution, the F distribution, I should say. You find the critical value for a ANOVA that has 3 degrees of freedom for the between groups variance and 24 degrees of freedom for the within groups variance, and you find the critical value. Of course, it was rather low. I forget what it was exactly off the top of my head, but 49.06, of course, exceeded that at the 0.01 level, which is why we have a less than 0.01 statistical significance level. Okay. So just to summarize here, what's really nice about the source table is that it's a really good way to organize a lot of the elements, the things that are going on in your ANOVA. You can use those for later analysis. And of course, I'll show you how to do this as we talk about the effect size and how to calculate the effect size measures. It's also a nice way to check out your calculations because you can kind of go through and see the sum of squares for the between groups variance plus the sum of squares for the within groups variance should equal the total sum of squares variance. Also, if you divide the sum of squares for the between groups variance by the degrees of freedom for the between groups variance, you should arrive at the mean squares for the between groups variance. And the same thing is true for the within groups variance as long as you're using those sources. Then, of course, the mean squares between divided by the mean squares within arrives at your f value. So as long as that all works out in your table, that's a pretty good sign that you did your math correctly. Of course, it's easy to make other mistakes there, but you can do that. Yeah, it's also a nice thing to communicate to your audience so that they, especially those who are statistically minded, can tell what's kind of going on in your data set and how it's working out there. Okay, so again, I'm going to show you how to use a source table and actually apply it when we're calculating the effect size measures, and we'll do that in the next video. I will see you then. Thank you.